Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. An oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane as well as the vertical plane. And since this line is inclined to both the reference planes, so neither of the front view or the top view they will be parallel to the XY reference line, and the projections of the line on the horizontal plane as well as the vertical plane will reveal only the apparent lengths of the line, and we are not going to obtain the true length of the line in the front view or the top view. So we need to apply the principles of rotation of the line in order to obtain the true length as well as the true inclinations of the line with respect to horizontal plane as well as the vertical plane. Here we have got a physical real life situation in which we have got a room which has got the dimensions, that is width equal to 4.5 meter, the depth equal to 3.5 meter, and the height which is equal to 3 meter. So into this room we have got an electric lamp which has been fixed in the center of the ceiling. So this is the ceiling or the top portion of this particular room. So this is the top of this room or the ceiling of this room. So into the center point a lamp which will be installed over there, and this lamp, it is connected to a switch which is located on the leftmost corner of this particular room, which is located 1.5 meters above the floor over here. So the switch, it is located 1.5 meter above the floor, and here the center point of the ceiling or the top of this room has been located. So once we locate the center point of the ceiling of this particular room, so here we are going to fix the electric lamp, and the electric wire, it is going to be connected between this electric lamp and the switch which is located onto the one of the side corners 1.5 meter above the floor. So we need to evaluate over here the shortest distance between the switch and the electric lamp over here, that is the length of this wire we need to evaluate. So these 2 points we can name as point A, which is corresponding to the switch, and point B, which is corresponding to the location of electric lamp, which is centrally located on the ceiling of this particular room. So this physical real life situation we need to convert into the projections of the oblique lines, and thereafter using the principles of the rotation of the line we are going to evaluate the true length of the shortest distance between the points A and the point B over here. So when we look at this particular room from the front, so we will observe that in the orthographic projections we are going to obtain the width of the room as 4.5 meter and the height of the room will be 3 meter over there. Similarly, when we look at this room from the top, so from the top we are going to witness the width of the room as 4.5 meter, and the depth of this room we are going to view in the top view as 3.5 meters over here. So we are going to use the scale 1 by 100, that is 1 meter is equal to 1 centimeter, that is 10 millimeter. So 1 meter distance of this room, width or height or the depth of this room will be represented as 10 millimeter distance in the orthographic projections over here. So the width of the room, which happens to be 4.5 meter, will be represented as 45 millimeter. Then the depth of the room, which happens to be 3.5 meters, will be represented as 35 millimeter. Similarly, the height of the room, which happens to be 3 meter over here, will be represented as 30 millimeter. So in the orthographic projections, the front view, it is going to reveal the width of the room as well as the height of the room. So the dimensions of the front view will be a rectangle which will be having the size 45 millimeter by 30 millimeter. Similarly, the top view orthographic projections, they will be represented as width equal to 45 millimeter and depth equal to 35 millimeter. Now, with this information, we are required to draw the projections of the line AB in the front view, that is A dash B dash, and the projection of the line in the top view, that is AB. And using these projections of the oblique line, we are going to obtain the true length of the line AB and the true inclinations of this line AB with respect to the horizontal plane and the vertical plane, that is the angles theta and phi. We are going to evaluate using the principles of the rotation of the line method. Now let us proceed with the construction of orthographic projections of this particular string or the electric wire which is going to join this switch which is located at the point A and the electric lamp which is located at the point B. So point B is, it is located centrally on the ceiling over here, whereas point A, it is located in one of the corners of the wall or the room over here. Now let us start with the front view. As we have discussed, the front view will be a rectangle having the dimensions width equal to 45 millimeter and height is equal to 30 millimeter. So here we have drawn the front view of this room, in which the width we have taken as 45 millimeter and the height of the room we have taken as 30 millimeter. Now once we have drawn this orthographic projection corresponding to the front view, now let us complete the orthographic projections of this particular room from the top. So as we have already discussed, from the top, again we are going to get the width of the room equal to 45 millimeter and the depth of the room will be equal to 35 millimeter. So width remains as 45 millimeter. Now we need to draw, this is the depth of the room. So this happens to be 35 millimeter. So the front view orthographic projection of this room we have drawn and the top view orthographic projection of this room we have also drawn. Now let us locate the location of this point B or the electric lamp which has been located centrally on the ceiling. Now once we are going to look at this particular point B or the electric lamp from the top, so we need to obtain the center point of the ceiling or the floor over here. So they are going to coincide with each other. So here the point B will be projected over here. We can check point B, it will be projected centrally. So here point B, that is small b, we will be obtaining over here. Similarly, projection corresponding to the point A, so this point A will be projected in this corner. So point small a, that is the top view corresponding to this switch which is capital A, will be obtained on this corner. It means we are going to obtain point A over here and point B, which will be projection corresponding to the electric lamp. It will be located centrally in the top view, whereas the projection corresponding to the point A, which is corresponding to the switch, which is located in the corner 1.5 meter above the floor. So this will be projected into this corner over here. So point A and point B, that is top view corresponding to the location of the switch and top view corresponding to the location of this electric lamp, that is small b. So both of these points, they have been located in the top view. So once we obtain point A and point B in the top view, we know that wherever point A lies onto the same locus line, my point A dash must be lying over here. Similarly, wherever Point B is lying in the top view. On the same vertical locus line, point B dash will also be lying. Now let us look at these 2 points in the front view. So in the front view, this point B, we can check it will be projected over here in the front view. As I am going to look at this particular electric lamp from the front, so I need to obtain the center point over here, center point corresponding to the width. So this point B will be projected at the center of this particular width over here. It is this point. So point B dash will be located over here. Similarly, point A dash, as I am looking at this particular switch from the front, I will be able to obtain point A dash 1.5 meters or 15 millimeter above the XY line in the front view. So I need to draw this distance of 15 millimeter, that is corresponding to the distance of 1.5 meters above the ground or above the floor. So once I mark this distance as 15 millimeter, so I will be obtaining point A dash over here. Point B dash will be located over here. So A dash has been located in the front view, B dash has been located in the front view, and once I join the points A dash with B dash, so the front view corresponding to this electric wire which is going to join the switch with the electric lamp has been obtained. So this is my apparent length of this electric wire in the front view, A dash, B dash. Similarly, AB. So this is the top view of this electric wire connection which is going to join this switch with the electric lamp. Now having obtained the projections of this line or the electric wiring in the front view and the top view, now we have converted this physical real life problem into the projections of an oblique line. So the projections of an oblique line AB, that is A dash, B dash and AB, they have been obtained. Now using the fundamentals of the rotation of the line method, we are going to evaluate the true length and true inclinations of this electric wire or the line AB which is going to join the switch with the electric wire over here. Now in order to obtain the true length of this line, we have drawn the locus lines through these 4 points. One locus line has been drawn through A, another locus line has been drawn through B, third horizontal locus line has been drawn through A dash, and another horizontal locus line has been drawn through B dash. Now, in order to obtain the true length of the line, we need to understand the basic fundamental of the rotation of the line method. Whenever the apparent length projection of the line in the front view, it becomes parallel to the horizontal plane. In the top view on the horizontal plane, we will be able to obtain the true length of this line AB over here. But in this case, we have got A dash, B dash, which happens to be inclined to the horizontal plane. So what we need to do, the rotation of the line method suggests that this apparent length projection needs to be rotated in such a way that this projection should be made parallel to the horizontal plane. So we should have our compass point or the needle point as A dash. We will be opening the compass equal to the distance A dash, B dash, and then rotate this apparent length projection in such a way that this point B dash should be rotated such that A dash, B1 dash should become parallel to the horizontal plane. So what we have done through this rotation we have been able to rotate this apparent length projection parallel to the horizontal plane. And the moment we have obtained this apparent length projection parallel to the horizontal plane, through this point B1 dash over here, we have to draw a vertical projector onto the locus line of the point B, and through this point B we will be able to obtain the true length of this line in the top view. So here from this point B1 dash, we will be drawing a vertical projector. You can check a vertical projector we have drawn through this point B1 dash. We will extend this line up to the locus line corresponding to the point B, and wherever these two lines they intersect, we are going to obtain the point B1 over here. And the moment we obtain this point B1, now we need to join A with B1 over here. This we have done using a blue line just to differentiate between the apparent length projection and the true length projection. So here AB1 will be the true length of this electric wire or the string which is going to join with the switch and the electric lamp within this particular room. Having obtained this true length, now we need to evaluate the angles of inclinations of the apparent length of this particular line with respect to the vertical plane. So this angle will be angle beta. So angle of inclination of apparent length, that is AB with vertical plane, will be beta. Similarly, the angle of inclination of the true length of this line or the string with respect to vertical plane is angle phi. So angle beta has been evaluated, angle phi has been evaluated, and the true length of the line in the plan has also been evaluated. Now we will also be evaluating the true length of this line or the string in the front view as well. So in order to obtain the true length of this line in the front view, once again according to the rotation of the line method, whenever the plan projection of this particular line, it happens to be parallel to the vertical plane, then its projection on the vertical plane, that is in the front view, we are going to obtain the true length of this particular line over here. So what we are going to do in this case, here we have got a plan projection AB which happens to be inclined to the vertical plane. But in order to obtain the true length in the front view, we need to ensure that this apparent length, it should be rotated in such a way that this apparent length should become parallel to the vertical plane over here. So with A as my needle point, I will be opening the compass is equal to the length AB and rotate this point B in such a way that this rotation must proceed up to the locus line corresponding to the point A, such that this point A and this point B2. So since this is the second rotation, so the name of this point happens to be B2. So AB2, which is the apparent length in the plan, we can check over here, AB2, it happens to be parallel to the vertical plane. So once this apparent length projection happens to be parallel to the vertical plane, so through the point B, so here we have got B2, we are going to draw a vertical projector onto the vertical plane. So once we have obtained this projector AB2 parallel to the vertical plane, so through this point B2, we are going to draw a vertical projector and extend it up to the locus line corresponding to the point B dash, and wherever this intersection happens, we are going to obtain the point B2 dash over here. So once we obtain this point B2 dash, now we are going to join A dash B2 dash, and this line A dash B2 dash, this is the true length of the line in the front view. Now having obtained this true length of the line, that is A dash B2 dash in the front view, and the true length of the line in the top view, that is AB1. So we must evaluate that these two true lengths, that is these two distances which are shown by blue lines over here, they should be equal to each other. Why? Because you cannot have two different true lengths corresponding to the same line. So once we obtain that A dash B2 dash happens to be equal to AB1, it means that we have followed the principles of the rotation of the line in an appropriate manner, and whatever solution has been obtained, it has been obtained accurately. Now once we have obtained the true length of the line in the front view as well. Now we need to evaluate the angles of inclinations of the apparent length, that is A dash B dash, and the true length, that is A dash B2 dash, with respect to the horizontal plane. And the angles of inclinations will be A dash B dash, it is inclined at an angle alpha with respect to the horizontal plane, that is the apparent length in the front view is inclined at an angle alpha with respect to HP. Similarly, the true length of the line, that is A dash B2 dash, it is inclined at an angle theta with respect to the horizontal plane. So here we can check that the true lengths of the line, they are greater than the apparent lengths of the line, and similarly the apparent inclinations alpha and beta, they are greater than the true angles of inclinations theta and phi with respect to the two reference planes. So this way we have been able to convert this physical real life environment into the projection of the oblique lines problem, and then using the rotation of the line principle we have been able to obtain the true length of the line in the elevation and the true length of the line in the plan. So the accuracy of this problem will be validated only when the true length in the elevation, that is A dash B2 dash, so this must be equal to true length of the line AB1 in the plan. So once we have evaluated this true length, so we have been successful in evaluating the true distance between the lamp and the switch. So this is all for today. So I hope that through this discussion you would have understood how we can go about converting a real life example into the projections of an oblique line, and also understand how using the principles of the rotation of the line we are able to obtain the true length of a line as well as the true inclinations of the line with respect to the two reference planes, that is HP and VP. So we'll be continuing with further discussion on few more such cases in the coming lectures. So thank you very much. Thanks a lot.